Hello, everybody. Hello. Hope you had a nice weekend. Hope you had a good time. My weekend consisted of grading essays for second years. That's what I do on my weekends. That's what I do. But here we are back at our lovely sociological analysis and research design course. So today we will basically continue the stuff that we didn't manage to cover last time. We will talk about descriptive statistics. Well, this is not a statistics lecture. You have another lecture for that. But I thought nevertheless it could be helpful to get into these things. So it's not going to be too crazy, too difficult. It's more about on the level of intuitions. I think this is very important, and I think at least that's where I often had my troubles, with lectures where I was in, that I didn't really get what the hell are those guys talking about, in terms of what is the intuition behind these kind of things. So that's, for me, the motivation to talk about these things here now today. Okay, before I start, a bunch of announcements. As I already said last week, a reminder, there's going to be no lecture on Wednesday. As already mentioned at the beginning of the term as well. So after this lecture, the next one is the following Monday. And on that Monday, I'm constantly thinking about how to, what can I do with you guys? Something, how can I entertain you? What can I do? So there's going to be some excitement on the Monday. Actually, we're going to get visitors from RTE. So we'll have RTE coming into this class. Your chance to go to the hairdresser before if you want to. So the reason for that is we here at UCD, we are involved in a larger study that I might have mentioned before. It's not just me, there are other guys in my department and so on, but I'm involved in this as well and will be busy with it over the summer as well. It's a study about the young generation in Ireland. It's actually everybody, most of the people in here, right? So it's about generation what, what are you guys thinking, what are your values and things like that. It's a large study. The idea is to get, several thousand participants in that. There have already been a whole bunch of interviews with that. There's going to be a whole scientific complement to that. That's actually where we come into play. Right? I don't know where my summer goes away. But then there's going to be 2 big documentaries about this. They're going to be aired in September or in October, I think. I don't have the exact date yet, but I will keep you informed about that. And there they will present results from interviews, but also from a survey and so on. And as part of that, those guys are coming to visit us. How exciting is that? So, and it nicely fits into what I want to talk with you on that Monday as well, because there I want to talk with you about interviews, right? Field work, and these kind of things. And that's essentially what we did in that context. So it's a nice coincidence, or we planned it like that. And there's going to be some folks from RTE coming. Maybe I'm new to Ireland. I don't know those folks. I don't know. I'm completely oblivious. I have no idea about famous people in Ireland. But apparently this dude is going to be the face of this whole thing on television. So he's coming. I think his name is Eagle McDermott. He's coming to the lecture. So if you want to get to know those guys, but he was in The Voice of Ireland. I don't know. Anyway, so that's on Monday. Next Monday. How exciting is that? Okay. Next step. A bunch of people ask me about exams, so I know this is the time of the year where you guys are kind of freaking out. Like, what the hell? How is this going to be? And I'm going to be, how can I manage? How can I survive that? So I will talk more about that. One of the next lectures. I haven't prepared for this right now yet, so people ask me to narrow things down. I need to think about that first. If you actually objectively look at what we talked about, it's actually, for me, it's pretty obvious what the questions are going to be. It's pretty straightforward, actually. What a question could be and what cannot be a question, right? So if you look at the test exam that I put online, I think that's already very helpful. That could give you a good idea. But topic-wise, I might talk more about that. But don't freak out yet. The whole point about this is not freaking out, but at the same time, I need to tell you, you need to study for this class. This is a class where you need to study, but I hope to make it clear so that you actually know what you need to study and what you need to do to achieve a good grade. So if you study, if you attended the lectures, if you went to all the assignments, if you did all the readings, right, and if you study for this class, you're going to do great. But I might talk more about that. But not today. Another thing, the next assignment is due, or it should be up. It's not up, but hopefully it's going. I managed to put it up later on during the day. It's going to be the last assignment for you guys to do, and then for the last tutorial seminars next week. I hope to put it up later today for you to complete it. It's not up yet, but hopefully later today. Okay. So far about announcements at the beginning. Now let's move on. Take out your phones, take out your tablets, your favorite toothbrushes, electrical toothbrushes. Whatever you have, I have 2 questions for you. By the way, last lecture I had this up, I made a little mistake in my explanation between interval and ratio scale. When you look up the video for it, I kind of flagged it, I highlighted it, but it didn't really matter in that case. But maybe you know me by now a little bit, but something you could realize is that I like to ask you some difficult questions once in a while that are a little sneaky. So this one here is a little sneaky. For the exam, I won't be as sneaky, but here I am a little sneaky because it sounds pretty much like the question I asked you last time, but it's actually a different one. So the last time I asked you about the median, now I'm asking you about the mode. The mode is something else. And the mode is what we're going to talk about today. The mode actually, to calculate a mode, basically you can calculate for every variable that is at least on the nominal scale a mode, which is basically every variable. A mode is simply the category that most people ticked. That's what a mode is. A median is sort of the halfway point, and the mean is then when you take the average as you would normally calculate an average and how you think of an average. And for that, it needs to be interval or ratio scale. So here the correct answer is nominal. Okay, in that light now there's another question. So I ask you about the median. So what is the median of the following values? And then you see seven values here: 1, 3, 1, 4, 9, 1, 12. Okay, this is looking good, guys. This is looking good. Finally, there we are. The median is 3, indeed. I will talk about that in a second. As I said, the median is if I would line you up according to your size or to whatever value that you have. I order you guys along that, and then I walk halfway through, and then I stop, and then I look at you. That's sort of the value that we have here. So if I would do that with these numbers, I would order them, then I would have the sequence 1, 1, 1, 1, 3, 4, 9, 12, right? And I walk halfway through these numbers. I stand in front of the 3. That's the median in this case. The mode would be 1. Yeah, that's the number that kind of shows up the most often. The mean would be 4.428. That's if you would sum all these things up and then divide it by 7. And the last one, that's basically just the middle of the range. I don't think it has a name actually, but that's sort of, it's halfway between 1 and 12, between the actual values. But the median is if I take the values that show up and I look at 50% of the individuals have at least a value as high as that. That's how you can think about it. Okay, but we will talk about these kind of things now. Okay, here we are. So that's what I want to talk to you about now. But averages, that's basically just these mode, median, and mean stuff. These 3 different things. They are important to know, and once you know them, that's sort of as far as we get here. A little bit more when you talk about dispersion. Dispersion means how spread out are certain values, because I will show you that knowing the mean doesn't necessarily tell you something about the whole population. Then maybe the median tells you something, but even then you still don't know, is there sort of a big difference between the individuals in the population or not? That's sort of where this dispersion comes into play, and that's sort of what we call, an important term here is the standard deviation. So we'll get to a little bit, and I will walk you through how we do that. It's not too fancy, but I will just want to give you an idea about what this is. And at the end, if we have some time, we get into sampling distributions and what this whole thing about this normal distribution there is, which is sort of this weird thing that kind of pops up all the time when you're in this. But let me get started with mode, median, and mean. So that's sort of this idea of averages. First of all, we can, now we are in a world where we had collected data with surveys or maybe even with experiments or something like that, right? But now we're in the world where we're analyzing, call that quantitative data. There's a data set, there's certain variables and there are certain values on it and so on. And then you can display the information that you collected or the data that you collected in different ways. So here, if you remember, I asked you this question about the weight of a cow a few weeks back. What's the weight of a cow? And now I'm showing you the distribution of your answers. This kind of stuff probably you can relate with very straightforwardly. What this is really just the raw data. This is really just the stuff that you picked in. I asked you what is the weight of this cow on this picture that you showed you on the screen, and some people said, I don't know, is 1 kilogram. Others said 1,000. Others said 300 or something like that. So here, I cut off the extreme outliers because otherwise this graph would look very different. I want to focus on the middle of it. And that's what we call a distribution. That's what we call a distribution. So basically here you see most people mentioned a value around here. Actually this was 300. This is sort of the highest value, the single value that was picked by people. And actually in this case there was 18 people picking the value 300. Yeah? The whole thing is a distribution. We can present this information in a slightly different way. So what I want to introduce now is what we call histogram. Histogram is also stuff you probably have seen before, or when you read textbooks, you come across these things. Even papers that I write, I produce histograms with things like that. So a useful way to present this data that we collected before. Histograms is basically just grouping individuals together instead of just having one line for, here we have one line for each value that people picked, right? In a histogram we basically have these little groups, or we call them bins, and then we count how many people fall into a particular bin. And then you see different versions of that. So here I binned it according to 100 kilograms intervals. Here I binned it according to, I don't know, I think 20 kilogram intervals. So I looked at where did people fall, into which category, and then I basically ticked the box somewhere on this category, and that's kind of what is being shown here. But you see already with these histograms, I'm losing information. Right? I'm losing information because now I only know, if I would only look at the histogram, I only know that, I don't know, 21 people ticked the box from 0 to, or I don't know, had a value from 0 to 100. I don't know the exact value anymore. So with histograms, we lose information. But at the same time, we get a better idea about the distribution as well. So this can be helpful and can be useful. But what I actually want to talk about is, so we have now this information, we have this data, about what you think, what the weight of a cow is, and what do we do with that? Yeah? What do we do with that? And we could look at the whole distribution, and but how do I communicate that? Well, I can display that, right? But what we often want to do, we want to think about other ways of describing the data that we have in a simpler way, right? Like saying, this is the number that describes the data that we have. And to a certain degree, that's what we did. I looked at the average, I looked at the mean. What was the mean calculation, the mean guess, the average guess for the weight of a cow? And it turned out you guys were incredibly good on that. So that's one number that we can look at. Or we can also look at the spread, and that's sort of another number. And actually these two together give us a very good idea about how we could describe these distributions. And in some, basically this is what descriptive statistics is all about. It's really about just describing the data that we have. And then, we have these things like averages that come into play, but also these things about dispersion, how spread out are our values. Okay, and then we have, now we are already in the middle of that. That's sort of the most important descriptive way of getting towards an idea or a description of the data that you have. When we talk about averages, I calculated the average guess that people had for the cow, right? But now I already talked about these things before. The average is not the only way to get to this idea of what we call central tendency. Central tendency is sort of where do people, tend to centralize somehow with their guesses. Average is one way to go about that. Actually, this is what we would call the mean. But there are these other ones, the mode and the median. And they're defined in a very straightforward way. I already talked about them. The mode is simply the value that occurs the most often. The median is the value that is in the middle of the distribution. In our example at the beginning, it was 3. And the mean is the average overall the values. So now what I'm going to do, I'm going to talk about each one of these 3, one after the other, and I'm going to give you an illustration in the case of the weight of the cow data. Yeah. Okay. So the mode is simply the value that of the relevant variable that occurs the most often. You see the distribution here, and you see now the mode would be the highest peak. Yeah? So most people mentioned as a single value 300 kilograms. That's the mode. And you can see already when you now remember, I will come back to that later on a little bit, when you remember that we had these different scales that our variables can be on. They can be nominal, they can be ordinal, they can be interval or ratio scaled. Yeah. Now when you think about what these things mean, nominal basically just means different categories. There's no order in there. Right? You cannot say that, males or females are higher than the other ones, right? That's just 2 categories, right? It's not like a ranking that you could install on that. But what you can do, you can look at which category was mentioned most of the time, right? So that means you can for every variable that is on a nominal scale, which is basically every variable that is that you measure quantitatively at least, you can calculate the mode. Now, when you think that further, for every variable that is on the ordinal scale, that has an order in there, you can still calculate the mode. Well, let's say, or let's take another variable, let's sample for the next 10 days, or for the next 100 days. I sample the amount of rain that falls down here in Ireland. Sadly, it probably would be a lot. But I sample that, or I kind of generate a data set with that, right? And there could be higher days, lower days with rain, and so on. But I can maybe I find one day there, I don't know, which seem to have had the most occurrence. You know, one measure, one value that had the most occurrence, and so basically I can calculate a mode for variables that are ordinal, interval, and ratio scale as well. But I will come back to that in a second, and you'll see how it actually works. Okay, so it's really just the highest bar when you look at the distribution here. I have another example. You know, there's sort of a bunch of there are more numbers in here. What is the mode? Well, actually, this is a mistake here. It should be 1. Sorry for that. So the mode is 1. The value that shows up most often. Let me correct that. The mode here is 1. That's the value that shows up most often. Okay, so that's already the mode. Let's move on to the median. Most of you got that right as well. You know, as I said, the median is sort of the if I would line up all the values in one order, there already see there's order here. So that means I need to have my variable at least to be on the ordinal scale so that I can actually order them. And then I would walk through these values up to to the 50 to the middle mark in terms of 50% of my observations are now below or equal to where I stand right now, and this is where the median is. You can see actually the median can overlap with the mode as well, right? And in this case, actually, it is the case that the mode and the median have the same values, but they don't have to. Right? They don't have to. So, for example, in the little exercise that we had before, the mode was 1. But the median is not 1. And here we have the same thing. So now, same sequence of numbers that I had before. When you look at which number shows up most often, well, it's 1. That would be the mode. But what is the median? So now, actually, I made it already simple for you. I already ordered these numbers according to from low to high, and then I would walk halfway through. And as soon as I reach the middle point in terms of the number of my observations that I have, I walk through, I stand in front of the 3, so that would be my median. So the median is the value that is in the middle. There are as many values below or equal as there are values above or equal. Show you some other examples. So now let's say I would have some other numbers here. I would have more 3s in there. I would do exactly the same thing. I would line them up in the order, and I walk up to, in this case, it would be the 1, 2, 3, 4, 5, 6, 7th observation that I have there, or the 6th observation that I have there. I stand in front of the 3, and that would be my median. Regardless of that there are more 3s coming, this is sort of just I walk there, and then I look back, and I look at 50% of my observations. There could be another scenario. Let's say, what if you have an even number of observations? So now we have, we have 8 observations here. There's no 3. So what is the middle point here? What is the middle point? In this case, the median is calculated. Oh, another mistake. Sorry for that. The median in this case is 1.5. It's sort of in between. Okay, so that's the mode and the median. And now we come to what you guys are probably most familiar with, the simple average, although this can be more complicated as well. We can not have just the arithmetic mean, but we can have the harmonic mean or some other means. But now let's not get confused about that. The mean, and when we talk about simply the mean, we mean the arithmetic mean. The mean is the same of what many of us call the average. It is calculated in the following manner. You just sum up all the values, and then you divide them by the total number of observations. That's pretty straightforward. And if I would do that, you see now I would come up with this 421.94 kilograms. And there you already see the difference between the mode, the median, and the mean. Now the mean is actually higher than the mode and the median. Okay, so now simple example. Now I have fewer numbers for that. The average value of that, I would just sum up all the values. 1 plus 1 plus 1 plus 1 plus 7, it's 10, and I have 5 observations in there, so I divide it by 5, so the mean is 2. Yeah? So that's how you calculate. So that's mode, median, and mean. Here you see now an example of where these things actually can be very different. Yeah? And when we look at, for example, the income distribution. Now, this is a little example now about income distribution. This is sort of, from an American textbook, so we're talking about dollars here, but it doesn't really matter. When we look at income distributions, it really matters what you're talking about. Are you talking about the mean? Are you talking about the median? Are you talking about the mode? Yeah. And depending on which number that you convey, I don't know, you write a newspaper article or you tell somebody this is sort of what the central tendency of the income distribution is, you get very different values. So, for example, in this case, you see the mode, the people that have the single value that shows up most often. In this case, it would be 2,000. Here we are, this sort of where most of the people are. That's the mode. The median is actually in here. It's just a single guy. But it is sort of, if I would have lined all these guys up in one long line, this would be where I would stand after I reach 50% of the sample that I'm looking at. And the mean is actually much higher over there. Why is that the case? Well, because there's sort of this super rich guy up there. So obviously this guy is sort of pulling out the mean, while this guy is not pulling out the mode and the median that much. That's sort of the thing. So when you have highly skewed distributions, the simple mean might not be the best choice because it's heavily affected by those guys that are extremely rich or those outliers out there. So in that sense, the mode and the median, they are much more, they're less influenced by extreme values. Okay, so that's mode, median, and mean. And as I already had mentioned before, it really matters on the kind of scale our variables are on. Just as a little reminder, we had these 4 scales that we distinguish. Nominal scale, it's basically, could be sex, female, male. Ordinal scale, it's sort of a ranking, right? I kind of put you in a certain age group, for example, or a certain preference, you like it, you extremely like it, or you don't like it at all. There's sort of an order in there. We have interval scale, which means the distances between the categories are meaningful, right? So that I know that 10 degrees Celsius, when it's 10 degrees Celsius warmer, that means sort of the same difference from 0 to 10, from 10 to 20, in terms of, it's not like a massive increase suddenly that the 10 degree Celsius increase means something else. And with ratio scale, there's a meaningful zero point that we can talk about. Okay, and now if you followed, and if you have understood what these mode, median, and means are, it should be no problem for you to match these things together, right? So when we have when we have a variable that is on the nominal scale, the only thing we can do is we can calculate the mode. We cannot calculate the average sex. What is the average sex? And that doesn't make sense to talk about these kind of things. So we can only calculate the mode of such a variable. But when we have a variable that is on the ordinal scale, we can calculate the mode, right? We can count how many people show up in the most often, in which category is being ticked most often. But on the top of that, we have an order in our values, right? So let's exploit that information. And that's what the median does. Basically lines your observations up according to the value and then looks at the 50 percentile, basically the middle point if you would go through. But you still cannot calculate the mean. Why? Because in your ordinal variable, you only have a ranking. This is the first, the second, and the third. But what is the difference between the first, the second, and the third? Right, it's sometimes a little confusing because we use numbers that imply sort of equal distances. Say, well, 1 to 2 is the same as 2 to 3, right? But who says that is the case? Right? Maybe in this ordering, the ordering would have been 1, 3, 112, right? And it would have had the order, the one is highest, this is in the middle, and this is lowest. But the distances in between, they mean something different from one category to the other. So in that sense, you cannot calculate the mean, but you can calculate the median. And you basically just order them, and then you look at, okay, what is the value when I look back? Which value which is greater or equal than 50% of my observations when they are ordered. That's the median. Okay, and then we move on to interval and ratio scale, and in that sense, I had this confusion the last time here, because both of these things you can calculate the mode, the median, and the mean, because now the key here really comes into play here in the interval scale, because with the interval scale, the distances between the values that you have are meaningful. That's why it's called interval scale, because there are intervals, and these intervals are sort of the same. They are meaningful. And in order to calculate a mean, you need to have meaningful intervals. Okay, so that's sort of how these things are being matched to each other. And I don't know, people ask me as just an example. This would be such an exam question. Yeah? I don't know, explain mode, median, and mean. I think it's even in the test exam. Yeah? And match it to which level, which scale the variables have to be at least. Okay, so that's averages. Yeah. But now let's move on to what we call dispersion. Yeah. Dispersion. So what is dispersion? Dispersion is a fancy name that simply refers to the spread of values around your mean, your mode, or your median, your measure of central tendency. That's how values are spread around this middle category, whatever that is. Well, why do we do that? Why are these things important? Well, I have a little example that I'm going to bring here. I teach second years, I let them play quizzes as well, and so on. Now let's imagine that I had them split up into different teams, A and B, and in each one of those teams I had 10 students. It's not as many people as here, so I do these smaller group exercises and funny things with them. And now, they got points, these different groups, from 0 to 100 points. And both of these groups scored on average 81.5. Yeah. So can we say now that these two groups are, as the averages are the same, that the students did pretty much the same? Can we say that? Well, not necessarily. Now let's look at that. So now this is now another way of presenting this data. This is really just a simple plot, similar to the distributions that I showed you before. Now the dots in here, they represent my data points, and when they are, you basically see the scores that individuals got. Yeah? So in the first group here, let's say there was one individual who scored 71, there was another one who scored 76, and so on. There were actually two individuals that scored 80, and so on. Yeah? So this is how you read this figure. And if I would go, take out of those 10 students, I take the mean. Now I take the average. I can do that because the scores that they get in a test that's on the interval scale. Actually, it's even on the ratio scale because an absolute 0 point as well. Or they could score 0. Yeah. And I can calculate the mean. And the mean is this value here. It's 81.5. There's no single individual that scored 81.5 in this test, but this is the mean. This is the average score that I have. Okay. Now let's look at the bottom graph. Now you see the distribution of the scores for my students in the second group. Call them team B. And now you see this looks quite different. So now I have some really good students. Some students here scored really, really high. There was one student who scored 98 points, while there was also one who scored barely above 55. Yeah? So now you see this is obviously a different outcome here. But the mean, if I would go and calculate the mean, doing exactly the same thing, sum up all those scores, divide it by 10, there's the number of individuals that I have in there, I would also come up with 81.5. So in this case, the mean would be exactly the same. So the average does not tell us anything about the distribution. That's kind of what we call the distribution or the variation in these grades. Are there some that are very high and some that are very low, right? could be maybe some are exceptionally good and score 100, and some others, they are extremely bad and they scored 0, but still my average could end up somewhere around the 80s, right? So we want to have we want to get some idea about how these things are spread out. And that's what dispersion is. So how spread, but also the spread of the distribution of our data. That's what dispersion is. And there are different ways how we can do that. The simplest one, very simplest one, is what we call the range. It's very simple, but it might help us to get to the way I want to take you. So the range is simply the difference between the highest and the lowest value in a distribution. Yeah? I look at who scored the highest, who scored the lowest. That's in between is the range. And I go back to the data about those student scores, that I had. Here are sort of these graphs. Now you see what the range is. Yeah? Just look at the difference between the highest and the lowest score. So in the above graph for the team A, the range is much smaller than for the second team, in the second group. And there you see. Now, having these two pieces of information, the mean, the average where we are, and the range, it gives us a much better idea about how this distribution looks like. Because at the end, we want to. I cannot tell people about the results of 500 students what their average guess for the cow was. That would be a pretty boring paper to write. If we would list 500 guesses. That the idea is to generalize somehow. To get summary measures. This is where these descriptives come into play. Okay, so that's the range, but the range is problematic in itself. Why is that the case? Well, let's look at this example. Now I have, again, this is sort of a distribution. Let's not worry about what it actually means. It just means that most of the people, you scored 19, whatever that is. Yeah? And we get an average that is in between here, right? And we get a range. But now you see we get a really long range, while actually most of the action, happens here in between. This is where most of the people are. The range wouldn't cover that. The range would just take the maximum and the minimum and look at the difference between the two. So this is now where the standard deviation comes into play. The standard deviation, something that you most likely heard in your stats class, right? Standard deviation is a measure for dispersion that captures this idea that there might be more action towards the mean. So the standard deviation is a number that measures how far away each number in a set of data is from the mean. That's all there is. That's all there is. And when you look at your stats book, there's a fancy formula for that, but this is all there is. Essentially, you calculate your mean, what is the middle score, and then you go and then you look at how far away are my observations on average from this mean that I calculated there. That's what a standard deviation is. Then you can interpret that in the following way, that when your standard deviation is large, it means that the numbers are spread out, are very far away from their mean. Right? That there are some students who score 100 and others who score 0, then my mean would be somewhere in the middle, and the distances between the mean and each student would be really high. While if everybody scores around 80, some score 80 and others score 82, and my average ends up somewhere in 81.5 or something, then you see, then the spread is very small. So then the values are very close to the mean. That would be captured by a small standard deviation. Okay, but I have brought some example to walk you through that. As I said, there are no formulas here, but I think it's important to get the intuition right because these things come back and come back and come back. Okay. So now let's look into detail of the results of the student scores that I had. I have 10 students in this first group and 10 students in the second group. Let's call them Team A and Team B. This is sort of the values that I have. Right? The mean would be 81.5. This is where we are. This is again sort of the result that we have here. Okay. Now we could go and now we could, after we calculated the mean, now we can go and look at the difference between each observation that we have and the mean. Let's start with the lowest score. So in this case, the lowest score is 72. Now we can look at how far away is 72 from the mean. It's 81.5. There we are. That's sort of the difference between the mean and the lowest score. And this difference is minus 9.5. Now I could go and do this for another score. Let's do this for the highest score, which is 89. Yeah? Now I'm on the other side. Now again, I'm looking at the difference between my score and the mean. In this case, it's 7.5. Yeah? Here we are. Now I can add that, to my observation that I have. At the top, you see the difference from the lowest score to the mean. At the bottom, you see the difference from the highest score to the mean. I can go on. And this is sort of the first step that you need to do when you calculate the standard deviation. Nowadays you have programs that do these things, and in the tutorials you will use some programs that do these things. But as I said, it's important to get the intuition of what these things actually mean and what they tell you. So now I can do that for each observation that I have. Let's just taking the values that I have here and subtract the mean from it. It's as simple as that. Then I get these scores. So I have the distances from the mean for each observation. And then to calculate your standard deviation, you need to do 2 more steps. The first one is you need to square these differences. I'm not going to go into detail why you do that, but there's some very good reasons why you do that. It's to do with this guy called Gauss and, interesting folks. Actually, even the guy called Galton. Yeah? You remember the guy with the wisdom of the crowds with the cow? This guy, he's actually very closely related to these kind of things, yeah? And to the normal distribution, but I come back to that in a second. So you can square that. What does it mean? Squaring means 9.5 multiplied by 9.5. I was just squaring these things. The nice thing that comes out of that is that the minus sign disappears. Multiply something negative with something positive. We can do that for each one of these distances to the mean. And these are sort of our distances squared. That's the second step. We calculate that. The third one is we sum these things up. We got a number. In this case, it will just really add 90.25 plus 30.25 plus 2.25 and so on and so on. I would end up with 214.5. That's the sum of the distances squared. And then for the standard deviation, you divide that by the number of observations that you have minus 1. In this case, it would be 10 minus 1. There's a whole other reason why it's 10 minus 1 and not 10, but I leave that for the stats class. It's called Bessel's correction. But here, the only thing we need to know is that we divide that by n minus 1, and then we end up with a score of 23.8. That's actually called the variance, and then we take the square root of that, and there we are with 4.8, right? But these kind of things, that's what computer programs do for you. But now I walk you through the steps once, so you know actually what is happening. So that means finally our standard deviation in this case would be 4.8. What does it tell us? Well, actually it tells us a whole bunch of interesting things. It tells us that we have the mean of 81.5, and it tells us actually that in this case 68.4% of our observation lie within an interval plus minus 4.8 around the mean. Where the 68.4 is coming from, let's leave that aside for a moment, but that's basically the normal distribution. And I have a graph for that, because it also tells us that 95% of the observations lie within an interval, actually they lie within an interval of 2 standard deviations around the mean. Yeah. That's kind of the stuff that you have to do in your stats class to calculate these kind of things, but I won't bog you too much with that. But what I want to show you now is I can do the same thing for my second t. Now remember I had this other distribution of folks that were kind of more spread out. Here we are. I calculate the distances from the mean, same thing. I square them. You see the number's already much bigger. I sum it up. It's a much bigger number. Divided by 10 minus 1. Take the square root of that. So there I have now a standard deviation, which is not 4.8, but which is 15.91. That's just an example here. But the thing is, now you see the data again at the bottom and how the distributions look like for these 2 different groups that I had. In both cases, the mean was the same, was 81.5, but the standard deviation is different. That's sort of this piece of information that we didn't have when we just looked at the mean. Yeah? Now we know that in the second group it's more spread out because the standard deviation is higher. I had mentioned these things about the normal distribution before. Oh, that's sort of this fancy graph here that keeps popping up, which is really fascinating where it comes from. Basically, the idea is that a lot of things in the world are normally distributed. It goes back to Gauss, this guy Galton. There's a mean in between, we call it mu, and there are standard deviations, which we call sigma here, -1 sigma, +1 sigma, and then a certain fraction of our observations lie within these intervals. So before I send you away, I want to show you actually how this normal distribution, where it comes from, an intuition for that. Because it's really, I don't know, in your stats class, I hope that you'll talk more about that. But what I want to give you is an intuition where this thing comes from. And I have a little video for you. So, oops. So what you see is, now I have some balls at the top here, and the different layers, and at each layer, there's sort of these little things. It's a little game. Sometimes you can play that. Kiddies play that sometimes. And at each where they hit sort of an obstacle, it can go either to the right or it can go to the left with an equal chance. And then once it goes to the right, then it goes further on somewhere, and then it can again go to the right or to the left with an equal chance. And then again with an equal chance to the right or to the left. When we would keep playing that, how magical is that? What comes out at the end of the day is the normal distribution at the bottom. That's how you can think intuitively of the normal distribution. And this is interesting for sampling. We talk about sampling a lot the last two lectures. When you sample certain individuals from a population, you don't know how a certain value is distributed in the population, but I can tell you, if you would go on, if you would do a lot of samples, the sample mean would also follow a normal distribution. That's not this crazy thing. That's actually called that's the central limit theorem. Again, I hope that your stats class will talk about that. I'm not going to talk about that, and there's going to be no question in the exam about the central limit theorem. But this is sort of the intuition for that. Okay, so no lecture on Wednesday, and be shiny for RTE on Monday.